Let's say you've got a canvas that has things on it, and you want those things to be in front of other things or behind them. So you assign each of them an index, 0, 1, 2, 3, 4. And then you render the items back to front, starting with the lowest index. That works great. So now you want to give the user a way to move those things forward and backwards. Let's say a user wants to move the back item to the front. Well, the back item is at 0 and the front item is at 4. So let's make the back item's index 4 and then make the old 4 a 3 and the old 3 a 2 and the old 2 a 1 and the old 1 a 0. That works. But your canvas might have thousands of shapes and you've just caused every shape on your canvas to update and maybe render too. Worse if your canvas is collaborative. And depending on how your collaboration engine works, you may have also produced a canvas-sized diff that needs to be sent to every other collaborator, which might conflict with anything being made at the time by other users. Well, okay, then how about we just make the old 0 item a 5 instead? Now it's the new highest index and everything still sorts correctly. We've only changed one shape and produced a tiny diff. That works for move to front, but what if we want to move it back one step? So far our indices have been integers, whole numbers. But okay, you'll use decimals instead, floating points. Now the old 5 is a 3.5. But what if you then move the old 3 up by 1? Now the old 3 is between 3.5 and 4. Which means its index will be 3.75. And if we move the old 2 up, it'll be 3.625. And if we move the old 1 up, it'll be 3.5625. And if we keep this up, we're going to run out of numbers because we're adding a number each time we split. And in JavaScript, floating point precision only goes up to 15 digits, 17 if you're lucky. So after just 52 splits, we'll be out of numbers. Right, so decimals won't work. But hey, aren't we just sorting things? JavaScript can sort numbers, but JavaScript can sort strings too, right? And doesn't JavaScript sort numbers as strings anyway? So let's ditch numbers, which won't have enough fractional precision, and use strings instead. We can come up with a representation that includes numbers, lowercase letters and uppercase letters for a total base of 62, which includes both integer parts and fraction parts, with each character adding about 6 bits of information. The string can be as long as it needs, supporting an almost infinite number of splits. But luckily, even just 10 characters will support 800 quadrillion splits. Done, right? Not yet. Not if your canvas is collaborative. If it is, then it's possible that 2 users will move 2 different shapes to the same index at the same time. Since indices are calculated on the client, you might have those 2 shapes end up with the same index. Now, this won't immediately crash the app, but it will later if someone tries to move a thing between those 2 identically indexed things, minutes or hours or days later. That's when their app will crash. So, the last thing you need to do, in order to prevent 2 users from moving 2 shapes to the same index, is to have each user add a tiny amount of randomness to every index they create, just enough to make the odds of a collision, in this already extremely rare circumstance, close to 0, that you can sleep through the night knowing your users are moving shapes forwards and backwards on the canvas. tldraw.com.
You want to do another